Hello everyone, let us start with the next example of vector. Find the constants m and n such that surface, this is a equation of one surface, we call it as phi 1, will be orthogonal to the surface. This one surface call it as phi 1, this another surface we call it as phi 2, and the given thing is these two surfaces are orthogonal to each other. Okay, orthogonal means their corresponding del phi 1 and del phi 2, these are intersecting each other at 90 degree, means their dot product is 0. Okay, this is a given thing. Now it is a particular at a particular point 1 minus 1 2. Now using this information you have to find out the values of m and n present in the first equation. Okay, let us start with the given thing. Let phi 1 is the first surface, mx square minus 2nyz, and take this on RHS side, LHS side, minus, it will become minus m plus 4x, and this is second phi 2, 4x square y plus z cube minus this 4. Now these two are orthogonal, therefore at a particular point 1 minus 1 2, therefore their dot product of their normal vectors, their del phi 1 dot del phi 2 is 0, because if two vectors, we know this, two vectors a bar and b bar are orthogonal, means a bar dot b bar is equal to 0. Okay, this is the theory. Now using this equation we have to solve the equation. This is the given equation in the example itself. We have to just solve it, and using that given information we have to find out the values of m and n. Okay, let us start with the del phi 1 first. We have to calculate both the equation, both the entities. First one is del phi 1. Del phi 1, where the phi 1 is a function of x y z, right? Therefore del phi 1 is a normal vector which is gradient of phi, and value of definition of gradient of del phi is, instead of phi just replace phi 1, del dabba phi 1 by dx I dabba phi 1 by y dabba y j plus dabba phi 1 by dabba z k. Dabba means derivative of phi 1 with respect to x, where it is a partial derivative, y and z are constants. Therefore phi 1 derivative with respect to x is 2x here, 2mx, m and n and other constants are, as keep that as it is. Here x is not present, therefore its derivative is 0, and here derivative is minus m plus n, means take this minus inside, minus m minus 4, it's I as it is, plus dabba phi 1 by dabba y, means derivative of phi 1 with respect to y is present here, minus 2nz, and nowhere j, plus dabba phi 1 by dabba z, derivative of phi 1 with respect to z is present here only, minus 2ny. Rest of other things with respect to apart from that variable is constants. Okay, that is the only rule for partial derivative, k as it is. This is del phi 1. Similarly we find out del phi 2, derivative of phi 2 with respect to x, y and z. Here treating with when taking derivative with respect to x, treating y and z constants. Okay, now at a particular point these two surfaces are perpendicular or orthogonal. Orthogonal means perpendicular. Therefore we have to put this point which is given in the example, which is a common point which lies on the both the surface. Therefore we should put this point in this equation. At the point this del phi 1 becomes, put the value of x is equal to 1, y is equal to minus 1, z is equal to 2. Here we get del phi 1 is equal to this one, and del phi 2 at point is this. Okay, putting x y z values are this. Now once we get this del phi 1 and del phi 2, put these values here in the equation. We get del phi 1 dot del phi 2 is equal to 0 implies multiplication of these two vectors. How we multiply two vectors? By multiplying their corresponding ijk coefficients. This ijk coefficient is m minus 4 into minus 8. minus plus minus 4n into 4 is 16n, and plus into plus 12 into 2 24n. Corresponding ijk coefficient should be only multiply and add. This is a dot product of two vectors is equal to 0 as it is on RHS side. Now we have to solve this equation. Using solving this equation, we get one equation in m and n, that is m minus n is equal to 4. Now to find out value of m and n, we need one more equation in m and n, right? So in the example, this point is given, which is commonly present on the both the surface. That's why whenever if you suppose this is one line, okay, suppose, okay, and this line equation is x plus y is equal to 1, and if we say one particular point, suppose 1 and 0 set lies on this line, then what does this mean? This means this point must satisfy this equation of line. Means putting x is equal to 1, y is equal to 0, we get 1 is equal to 1, which gets equation gets satisfied. The same logic we have to apply here. If this point set as present on both the surfaces, therefore this point should satisfy both the surfaces equation. Okay, now we have to see in which equation or in what equation of a surface m and n present. In first equation of a surface, m and n are present. In second equation, no m and n there. Therefore we are going to use the first surface equation. Therefore put this value of x y z, that is point, in this particular equation, because the point lies on the surface, therefore it must satisfy this equation. We get another equation in m and n. Okay, the same logic we are going to apply here. Point this lies on the both the surface, therefore point satisfies the both equation. Put this point in the first surface, we get this equation. Putting x is equal to y is equal to z is equal to 2, we in the first equation we get this equation. Now simplify this. By simplifying, m gets cancelled. Directly we are getting n value is equal to 1. Put this n value here, we get m is equal to 4 plus 1, that is 5. Okay. Let us see next example. If maximum directional derivative of phi, this is a given surface, at a particular point has maximum magnitude 64, okay, in the direction parallel to z-axis. This is the given information. Now find out value of a, b and c. First let us see what is the meaning of maximum directional derivative. Directional derivative is maximum in its own direction and its magnitude is given by magnitude of del phi. That means we have to find first we have to find del of phi, and then we have to move forward. Let us find first del of phi. Del of phi by definition it is dab of phi by dab xi, dab of phi by dab yj, dab of phi by dab zk. Phi derivative with respect to x is this, with respect to y is this, with respect to z is this. Simple derivatives. Okay. Now at a particular point is given, that's why put this point here. We get del phi is equal to this. Now directional derivatives has maximum magnitude 64. Magnitude is given, which is 64. In what direction it is magnitude? In the direction parallel to z-axis. Now we know parallel to z-axis or on the z-axis we have one vector which is which lies on the z-axis. Unit vector is k. Okay, therefore this is maximum magnitude in the direction of this k, therefore del phi is equal to 64k. Why it is? Because directional derivative is maximum in its own direction, and which is given by del phi only, and its magnitude is magnitude of del phi, therefore it is equal to the that directional derivative which is present in the similar direction or parallel direction. Therefore 64 is its magnitude and k in the direction of k or z axis. Therefore the equation we have to write down, that is del phi is equal to 64 into this k. It is like del phi is equal to 0I plus 0j plus 64k. Okay, now we have to solve this one more equation. Now put the value of del phi is this as it is, 64k as it is. Now this is one vector ijk, any expression which contains ijk, any one of the ijk or all of the ijk, three of them, it is a vector, and equal to this is k means this is also a vector. That's why two vectors are equal means their corresponding coefficients are equal. Here 64k means 0I plus 0j plus 0k. Therefore, coefficient should be compared. We get this coefficient is equal to 0, this coefficient is equal to 0, and this coefficient is equal to 64. Okay. Now this is simultaneous equation in A, B, C, and C. Solving this, we get this answer. A is equal to 6, B is equal to 24, C is equal to minus 8. This is simple arithmetic. Okay. Now let us see next definition. Divergence of a vector. Let a bar be any vector such that a bar is equal to a1i plus a2j plus a3k. Okay, then divergence of a vector a bar is defined as divergence of a. In short, it is written as divergence div of a bar is equal to del dot a bar, which is nothing but del dab of dab x of a1 plus dab of y, derivative of y with respect to of a2 with respect to y, derivative of a3 with respect to z. Addition of this, it doesn't contain ijk. This is a definition of divergence. And curl of a vector is nothing but same, let us consider the same vector a bar, and it is defined as curl of a, curl of a, which is equal to del cross a bar. This is a dot product. D for dot product, divergence means dot product. C for cross product, curl, which is nothing but this is a simple definition of cross product, where first row is ijk, second row is coefficient of del, which we know del of dab x, dab of y, dab of z, and third row is second vectors coefficient a1, a2, and a3. Okay. Now note, if divergence of a bar is equal to 0, then a bar is called solenoidal vector. If curl of a bar is equal to 0, then it is called, the vector is called the irrotational vector. These are some short notes in exam they can ask for objectives. Okay, let us see the examples. Find values of lambda. We have to find out lambda value such that vector field, this is f bar, is solenoidal. Now we have to know when the vector is solenoidal. This is the theory. Vector is solenoidal if its divergence is 0. Therefore, we have to find out first divergence of f bar. We know f bar is solenoidal if divergence of f bar is equal to 0. Now call it this as f1, this is f2, and this is f3, because we have to apply this derivative definition. Therefore, divergence of f bar is equal to del dot f bar is equal to this is derivative of f1 with respect to x plus derivative of f2 with respect to y plus derivative of f3 with respect to z, which is 0. Okay, because it is given, it is solenoidal. Now simplify this equation. F1 derivative with respect to x is this, f2 derivative with respect to y is this, f3 derivative with respect to z is this, which is equal to 0. Now take xy square common from the all of the three terms. We get 4 plus 9 plus lambda. Take this divide by xy square, we get 9 plus 4 is 13 plus lambda is equal to 0. Therefore lambda is equal to minus 13. If, next example, if del dot f bar means divergence of f bar, we have to find out divergence of f bar, where f bar is gradient of this function x cube plus y cube plus z cube is equal to minus 3xyz. Gradient and del is a different, having different this thing, because see, gradient is having same formula, del dot phi is called gradient of phi, grad of phi. But when where phi is a scalar function, it is not a vector. It is a function like this, function of x, y, z. But del dot f bar is called as divergence of vector f bar. Okay, these are the two different things. Where gradient of phi is given by, we know del phi is given by deva phi by deva x I, deva phi by deva y z, deva phi by deva z k. This is a vector. Okay, while this in this case it is given by del of f bar is nothing but deva f1 by deva x plus I is not there, deva f2 by deva y plus deva f3 by deva z. That's it. This is a scalar quantity. Isaac means vector and others are scalar function. They are called scalar function. Now first we have to find out, before finding del dot f bar, we have to find out f bar. And what is f bar? It is a gradient of this. That's why we have to find out the grad of phi, means del of phi, which is definition this. Now phi is this. Therefore grad of this is nothing but def of phi by def x, derivative of this with respect to x into I, plus derivative of this with respect to y with into j, plus derivative of this with respect to z into k. This is gradient of phi we get. Now this is called f bar. It is already given. Therefore we have to call it as, because we have to find out del of f bar, divergence of f bar. Therefore call it as f1. This is f2 and this is f3 with sign. Okay. Now del dot f bar is definition this. Put the value def f1 derivative with respect to x, f2 derivative with respect to y, f3 derivative with respect to z. It doesn't contain I j k, while the gradient contain I j k. Okay. Now take 6 common. Answer is this. Okay. Now next, if f bar is equal to, it is given x plus y plus 1I plus z minus x plus yk, then prove that f bar into curl of f bar is 0. First, f bar is already given. We have to find out curl of f bar. Curl of f bar is first row I j k, second row def of def x, def of def y, def of def z. Third row is f bar x y z coefficient. I j k coefficient x plus y plus 1 here. Here coefficient of j is 1 and here coefficient of k is minus with sign, minus y minus x minus y. Now solve this determinant, 3 by 3 simple determinant. We get curl of f bar is this. Now take the dot product of f bar into curl of f bar. This is f bar original and this is curl of f bar. Now this is dot product of two vectors. Therefore corresponding I j k should be multiplied. This into this minus 1, 1 into this plus 1 and this minus x minus y into this minus 1. Okay, solving this we get all the terms gets cancelled. Answer is 0. Let us see next. Find curl of f bar where f bar is del dot mean divergence gradient of this phi. Okay, now in earlier we are same question is there, but we have to find divergence of f bar. In this question we have to find curl of f bar. Okay, now we have to find first grad of phi, which is already in the earlier example we have solved. Directly write down, we are going to consider this. This is f bar, gradient of this function. This is, call it as f1, this is f2, this is f3. Okay, now curl of f bar means del cross f bar, means first row is I j k, second row this fix, these two are rows are fixed for curl, and third row is f bars I j k coefficient f1, f2, f3. Okay, now solving this, I into derivative of this with respect to y is minus 3x, cross this derivative of z, and derivative of this with respect to z is minus 3x, and minus sign is there, that's why it becomes plus. Minus middle sign j, minus j into this def of def by x of this, derivative of this with respect to x is minus 3y, because it is constant, derivative is 0. This into this, derivative of this with respect to z and minus minus plus 3y. Now plus k, derivative of this with respect to x is minus 3z, minus derivative of this with respect to y, it becomes plus 3z. Now if you observe, all the terms gets cancelled and answer is 0. Okay. Now let us see next. If r bar is, we know it is a position vector xi plus yz plus zk, then prove that del dot r bar is equal to 3, del cross r bar is equal to 0. It is very simple. Dot product of two vectors. We know del of dot r bar is dab of dab x of I coefficient is here plus dab of dab y. We know need to write down here f1, f2, f3 because these are our simple terms, plus dab of dab z of this coefficient z. Derivative of x with respect to x is 1. Derivative of y with respect to y is 1. Derivative of z with respect to z is 1. 1 plus 1 plus 1 is 3. Now consider cross product. Del cross r bar. First two rows are same. Third row will be r bar's x, y, z coefficient, I, j, k coefficient, x, y and z. Now taking I into this, derivative of z with respect to y is 0 minus derivative of z, y with respect to z because it is a constant. With respect to z, y is constant, derivative 0, derivative 0. Similarly here also 0 into 0, 0 minus 0, 0 minus 0. Answer is total 0. Now let us see next. Find del dot f bar where f bar is given. Same we have to find out divergence. F bar is x by r I, y by r j plus z by r k. Let us call this f1, this is f2, this is f3 because there are complicated terms. Directly we cannot find out the derivative. Therefore, first write down derivative of definition of del dot f bar is dab by f1 by dab by x plus dab by f2 by dab by y plus dab by f3 by dab by z. Already as equation 1. Now consider derivative of f1 with respect to x. Here is f1. Derivative of f1 with respect to x. Numerator contains x, denominator contains r, and r contains x, y, z. Because what is r? We have already know this. R bar is xi plus yj plus zk, and r is its magnitude, under root of x square plus y square plus z square. Taking square on both sides, we get x r square is equal to x square plus y square plus z square. Okay. Now derivative of this we have to use u by v rule. Here v into r into derivative of x is with respect to x 1 minus u into x into derivative of r with respect to x is divided by x divided by v square is r square. Now separate, we know dab r by dab x is x by r, and separate divide this term, we get r upon r square 1 by r minus x into x upon r square into this x by r. Okay, now x into x becomes x square, r square into r becomes r cube. This is derivative of f1 with respect to x. If derivative of this f1 with respect to x is this, then derivative of f2 with respect to y, just replace x by y because these are three terms are similar to each other. And derivative of f3 with respect to z is just replace x by z. Okay. Now put these values, three values in this equation 1. We get del dot f bar is equal to addition of all these three. And these three terms are same. 1 by r, 1 by r, 1 by r. Therefore, it is 3 upon r minus 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 as it is 1 by r cube, 1 by r cube get common. In the bracket it remains x square plus y square plus z square. And we know by this definition x square plus y square plus z square is r square. Therefore, put the value of here r square gets cancelled. We get 3 by r minus 1 by r. Denominator is same, 3 minus 1 is 2 by r. Answer is 2 by r. Now, next consider next example. Find the rate of change of phi is equal to xyz. It is a given. Rate of change of meaning means, let us see first the question. In the direction normal to the surface, this in the direction, whenever this words comes in an example means we have to find out directional derivative. Okay, that directional derivative is in the other word, it is called the rate of change of. means directional derivative of phi. Okay, at the point is given 1 1 1. First, write down the rate of change of phi means directional derivative of phi in the direction of normal to the surface, call it as phi 1. Okay, I take this 3 on that side at a particular point, this. Now we have to find out directional derivative of phi, and we know in the direction of normal to the surface. We know first of find out normal to the surface phi 1. Normal to the surface phi 1 is del phi 1 at particular point. Therefore del phi 1 definition is this: dava phi 1 by dava x plus dava phi 2 by dava y, phi 1 by y, phi 1 by z. Now take derivative of phi 1, phi 2, phi 1 with respect to x and y and z. Put here simple derivatives. We get del phi 1 is equal to, this is derivative of phi 1 with respect to x, this is derivative of phi 1 with respect to y, this is derivative of phi 1 with respect to z.